So, good afternoon, students. And in last class, we have started with the third unit. In the last class, we have seen about the main difference and between DTFT and followed by the DFT. So, we have carried out many examples. We have seen many examples in the DTFT and DFT. So, in today's class, we might be going with the definition of DFT. So you already know the definition of DTFT, so we'll be getting into the definition of DFT. So DFT you can take it as the endpoint, the endpoint DFT of a finite of a finite duration, finite duration sequence x of n, sequence x of n of length of length L of length L, where your n value must be greater than or equal to L. Okay. So in this this you already know the basic definition between DFT and DTFT. So in a DFT, your samples will be of equally spaced. Okay. So what happens is that if you're taking DFT for over here means for x of n means this is the basic formula for a DFT of x of n is equal to x of k. It will be equal to, so for DFT you have to represent like this, x of k be equal to summation n equal to small n equal to 0 n minus 1 x of n e power minus j omega will be coming out. So omega value we already know. Omega value is 2 pi k 2 pi n k by capital N. Okay. So this is it. The formula for DFT, and in general this e power j term can be written as summation n equal to 0 n minus 1 x of n w n small n k. So here they are taking the 2 pi capital N as the wn. Okay. So this is for simplicity purpose. For computation during the problem, you can make use of this wn, and this wn is separately called as twiddle factor. Okay. So n minus 1. So this k value goes up to n minus 1. Okay. So now we'll be getting into the inverse of this DFT. The inverse is just the reverse process. So inverse IDFT is nothing but the inverse DFT, inverse DFT. So for the inverse DFT, you will be having the x of k, and what you need is the value of x of n. Okay, that's the reverse process we will be doing. So you can write the inverse DFT the inverse DFT of sequence x of k of sequence x of k, which is of length n. Okay, this is of length n. Of length n is defined IDFT over x of k will be taking, not on x of n. Okay, so similar to here, the inverse Z transform and inverse Laplace transform. X of k is equal to x of n. X of n is equal to 1 by n summation k equal to 0, k will be again, it will be going up to n minus 1. So this x of k value will be substituting here. Here will be putting e power j 2 pi nk by n, capital N. Okay, and now you substitute with respect to your Wn. Okay, we are substituting with respect to Wn means you will be getting 1 by n summation k equal to 0, n minus 1, x of k Wn minus n k. So here your n1 will be taking the values as for n equal to 0, 1, 2 up to n minus 1. Okay. So over here this Wn is nothing but your Twiddle factorizes. So you have to define the Wn. So your Wn is equal to your Wn is equal to e power minus j 2 pi by n. This is your value of Wn. So this is what with respect to your DFT and IDFT. So already we have seen about the comparative analysis between your DFT and IDFT. So, but I didn't give any point-wise uh, definition. So here I'll be giving out. So difference between DFT and DTFT. Difference between DFT and DTFT. Okay. So now we'll be seeing the main difference. So first thing, so your DTFT is nothing but DTFT is nothing but what is the DTFT? The Z transform. DTFT is nothing but the Z transform okay. So Z transform evaluated evaluated along the unit circle. Evaluated along the unit circle. Okay. It is centered at origin of origin is nothing but 0 comma 0. Origin of is that plane. Okay. This is what the DTFT. Okay. For DFT is nothing but the Z transform, the same Z transform. Okay, the same Z transform. The same Z transform evaluated at a finite finite number of finite number of equally spaced equally spaced finite number of equally spaced points equally spaced points on the unit circle centered at origin of Z plane. So now we will be getting a little bit clear idea that for DTFT, what we'll be doing is you'll be taking the Z transform along the unit circle. Okay, but over the DFT, you'll be taking the Z transform for a finite number of equally spaced points. Okay, so this is the main difference between these two. Apart from this, the other common points are the second thing. Okay, second thing. So DFT is a sampled version. Am I right? Because in your DTFT, you are taking equally spaced finite number. Okay, so it is something similar to the sampling only. Okay, so it is a sampled version of DTFT. DTFT. It is a sampled version of DTFT, uh, where where the frequency term omega equal to the frequency term is sampled. So the sampling quantity is nothing but your omega. Okay. But another one thing what you have to see is that the DTFT is the same point. The DTFT is obtained is obtained DTFT is obtained. How it is obtained? By using sampled form of input signal, right? Already the DTFT which we are doing is by sampling only, but the DFT is obtained by the double sampling, because DTFT is a sample. So again you have to sample it to get the DFT. Double sampling of x of t. Okay. This is the second one. So third one which I am going on means DFT gives only what it gives: positive frequency value. Positive frequency value, whereas because ADFT is done for a periodic signal, so you'll be getting only the positive value. But for the DTFT, both positive and negative frequency values are possible. So this is the third point. The next is the fourth point. DTFT and DFT coincides, that is, it meets, coincides at intervals of, just right, because DTFT is the entire thing. So the DTFT you are sampling out. Okay. For example, DTFT you can take it as a apple, and if you are cutting that apple into pieces, means you will be getting DFT. So again, if you are joining all the pieces of apple to, means you will again get the entire apple. Okay. So similar to that, these coincides at the intervals of omega equal to 2 pi k divided by capital N. Okay. So here k will be taking the value of k equal to 0 comma 1 comma n minus 1. That's the fourth one. So the last one is regarding accuracy. To get more accurate values of DFT, the number of samples n must be very high. Okay. For this you already know. For to get more accuracy, the number of samples must be very high. But this in turn, but it may lead to higher computation time. This you already know. The more the number of samples, the more the numbers it takes to a computation. Okay. This is what the primary differences between these two things. we'll be getting into the example. So after getting into some examples, we'll be going to your properties. So example one, what is this? Given three signals are given. Three signals. First one is A x of n. So x of n is equal to impulse function. Okay. Del n. So B x of n is given as del n minus n naught. It is just shifted. Okay. N naught. So where your 0 less than, you have to define the n naught. So n naught greater than, so less than n. Okay. This is less than the number of samplings. Okay. So C is x of n is equal to a n, okay, constant to the power n. So here you have to define the value of n. So 0 less than equal to n less than equal to n minus 1. Okay. To compute DFT, let us find DFT. Okay. We'll be starting out. Solution. Solution. So first one is x of n is equal to del n. So for this, we have to write the formula for DFT first. DFT colon x of k is what you need equal to summation n equal to 0, small n, this is n minus 1. So x of n e power minus j 2 pi by n into small n into k, small n into k. Okay. So what happened is that your k is defined for the same thing. This for a k will be take the value of 0 less than equal to k less than equal to n minus 1. Okay. So here they didn't give what your n value takes and what your k value takes, but you already know that x of n will be your del n. Okay. So your del n will be 1. Okay, 1 over the period of 0, and at the other part it will be 0, right? So you just recall that thing. So del n, so e power minus j 2 pi by n to n into k. Here, in general, you can, this is for your reference. So del n will take the value of 1 for n equal to 0 and 0 for other. Okay, this is for your reference. So if you are putting that over here means we'll be getting that, that is n, if you are putting is 0 means we'll be getting n equal to 0. So del n, and del of 0 is nothing but 1 e power, we taking 0, so we'll be getting the value as 1. Okay. Therefore x of k, x of k will be equal to 1 for 0 less than equal to k less than equal to n minus 1. Okay. So this is for here a. So if you're taking any kind of transformation, Fourier transform or DTFT or DFT over this kind of common signals, impulse function or unit function like that, if you're taking out means you'll be getting the same value only. now moving on to B is nothing but x of n equal to del of n minus n naught, n minus n naught. So you have to put the formula. So x of k is summation n equal to 0 to n minus 1. Okay, x of n e power minus j 2 pi. So you just write to the j 2 pi in the problem and all. Okay, j 2 pi by n to small n into k. Okay, now substitute the value of x of n, summation n equal to 0 n minus 1 del n minus n naught e power minus j into 2 pi by n capital N into small n into k. Okay, so now you already know your del n will be taking the value of 1. Okay, substituting n equal to 0 means what will be getting the final answer is e power minus, you just put the n equal to 0 alone, other values you don't need to put, because for other values it will be taking the value as 0 only. So putting n equal to 0 means it takes the value of 1, so del n similar to the previous one, so del n will be 1. Okay, that is del of 0 will be 1, but your n naught will be there. Okay, so e power minus will be getting like this, e power minus j 2 pi by n into n naught into k. The n will be varying into n naught. Okay, your n naught also has to be already defined as it is within the sample. So if it is within the sample only, this is possible. So you have to define k. For k value will be the same as the n value. 0 less than equal to k less than equal to n minus 1. Okay. The next is with the C. For C, it is given as x of n equal to a power n. Okay. So your x of k will be, with the formula summation n equal to 0 n minus 1. So you just write a power n directly, e power minus j 2 pi by n small n into k. Okay. Now this you already know. For this you will be putting the formula. For the n you just take to the outside. So you will be getting summation n equal to 0 n minus 1 a n, here also n is there, here also n is there, a power minus j 2 pi by n into k the whole power n. Summation power this is the constant, summation power constant n will be getting the value as 1 minus a, that is constant power n divided by the denominator, that is for 0 less than equal to k less than equal to n minus 1. We will be getting this value, you just put it out, 1 minus, so this a power n will be there, a power n, so e power minus j 2 pi, so n and n will be cancelled, 2 pi k divided by the same thing, 1 minus a e power minus j 2 pi by n into k. Okay. This is the formula. Okay. Another one example only can see. So example 2, Example 2, given it is a simple problem. X of n is given as a constant 1 0. Similar to the last C subdivision, you can see this for n is even, for n is odd. To compute DFT. The solution is just write x of k. X of k is equal to e power summation n equal to 0 to n minus 1 of n e power minus j 2 pi by n small n into k. Okay, this is the formula. So now what you have to do is they have given two values, one for even and another one for odd. So you have to define the odd and even function. So for this you have to put for n equal to, it will become odd and even means you just substitute the value of n as 2. Okay, this n will be changing to n by 2. Okay, so by substituting over that means you will be getting the values, and your function for and for even, your x of n will be tending to, you can take it as a 2n, and for odd you can take it as x of n plus 1 to 2n plus 1. Okay, now substitute this over the here, we'll be getting x of k equal to summation n equal to 0. So n by 2 you have to put n by 2 minus of 1. Okay, here it is capital N, x of 2n e power minus j 2 pi by n. Here another one n by 2 will be coming, this 2 will be carried over to here 2n k. This is for an even function. For odd function it will be coming with 2n plus 1. So this plus summation n equal to 0. So again the n by 2 minus 1 x of 2n plus 1 e power minus j 2 pi by n. Here it will be coming 2n plus 1 into k. Okay. So now upon substituting we will be getting summation n equal to 0 n by 2 minus 1 x of 2n e power minus j. So 2 you bring it inside, 4 pi by n into nk. Okay. So odd part you don't need. So odd part it will be taking 0. That's what they have given in the question. So odd part you can just omit it. Odd part will be taking 0. So plus 0 you can put. This value will be taking 1, right? So summation n equal to 0 n by 2 minus 1 e power minus j 4 pi k n by n. Okay. So now if you are substituting the formula for this, you will be getting final answer as x of k equal to 1 minus e power minus j into 2 pi k divided by 1 minus the same thing e power minus j 4 pi k by n. Okay. For the, so now you might have got a simple procedure for finding out your DFT. So in the next upcoming classes, I will be dealing with still more problems.